Okay, I'm going to start this video with a cube root function. It seems like you guys were having a lot of trouble graphing cube root functions when we were doing the review, so let's remember what the parent function looks like. It's a cube root, so you have a point at the origin because the cube root of 0 is 0. Now let's look at 1. The cube root of 1 is just 1, so I have a point at 1, 1. What about negative 1? The cube root of negative 1 when x equals negative 1, y is also negative 1. So we have a point there. And then it turns out that the cube root function ends up being like this, because if you take the cube root of negative 8, you get negative 2. And if you take the cube root of 2, you get, or 8, you get 2. Notice, this equation does not have an asymptote. The parent function does not have an asymptote. Functions like this don't have asymptotes. So although it looks bad, like I drew it kind of like it would have an asymptote, it's just gradually decreasing, okay? So there's no asymptotes. Let me maybe draw it a little better. There's no asymptotes. It's gradually decreasing. So that's our parent function. But we want to graph this guy, okay? So we are going to use a different color and graph it. Now, I am going to transform my point of inflection, which is right there. And this tells me I'm moving 3 units right, because I just switched the sign here. And I'm moving 2 up. So all I'm doing is I'm moving 3 units right. 1, 2, 3, and 2 up. So here's my new point of inflection. And then I'm just going to regraph. I'm going to just regraph. Now, that's kind of a bad graph, but there's my point of inflection, and yep, just regraphing it. Let me give you a better graph. Okay, I'm just regraphing my parent function for my new point of inflection. Okay, now, I have finally graphed it. My red graph is the correct graph. Now, what if the graph said that it was a negative in front? That would mean that it was reflected. What if instead they gave us a negative in the front? Well, if it was reflected, now look at my orange graph. I still have the same point of inflection, but it's literally just reflected over the x-axis. So it's going the other way. You see how this graph is a reflection over a line parallel to the x-axis, but going through the point of inflection? Okay, so if you are confused, the orange graph is this new reflected graph that I decided to do. The red graph is the graph of this guy right here without the reflection, and the blue graph is the graph of the parent function.